In our last episode, Mr. Strauss was trapped in a quantum coral caused by a standing wave pattern. Will he be able to collapse the wave function escape? We'll find out.
All right. So with some of these, there's going to be more than one possible answer. And let me just kind of point out some places maybe where your answers will deviate. And when it comes to the test, Brandon, you have to give me one possible correct answer. Okay, you don't have to give me all possible correct answers. At least one that works. So I think you guys are probably good with doing those guys and those guys. And yes, I'll take an error, Mulkey. Those should be half arrows, not full arrows. Okay, half arrows is the correct way to do it. I made a mistake. So probably where you might have made some mistakes is with the P's. So we have one there and one there. And it's probably just easiest if you give those the M sub L values of 1, 0, and -1. And it's probably easiest if you start in that one and just put one there and one there. So they're in the second energy level. You're in a P sublevel, and when you're in a P sublevel, L is 1. And then I have one electron in the orbital value of 1, and one electron in the orbital value of 0. And then I have them both spinning up. But you could have had them both spinning down. Again, I picked 1 and 0, but you could have done 1 and -1. You could have done 0 and -1. So there are a lot of options there. Yep, Rachel.
If you do 1 and like -1 or 0, the second one, because couldn't it be in the other one?
Yes. So if you wanted to put 1 there and go 0 or -1, that's fine too. So again, when it comes to the test, just one possible correct answer. For 7, your choices become limited because with nitrogen you have to have one in each box. You can't double them up. So if you have one in each, you must have one in the +1, one in the 0, one in the -1. The only places, Cassidy, where you could have some options is they could all be spin up or they all could be spinning down. For oxygen, now we have one more electron. And that electron, again, it's probably just easier if you put it in the first box there, Adam, but you don't have to. You could have put that electron in that box. You could have put it in that box. The only thing that it has to be is it has to be spin down. So here I've got, I just put it in the first box just to make it easy. So I have 1 in there, 1 in the 0, 1 in the -1, and then I just start repeating again. And I've got another one, my second electron in the +1. It's a -1/2. It could be or 0 or -1. Now on the homework I asked you to put that or in there, Emmy. Well, when it comes to the test, if you just do that, that's fine. Give me one possible correct answer. Okay, I asked you to do it on the homework so that I can see if you're doing it right. Because although these are a pain in the butt, Kelly, it's pretty easy to guess and get the right answer because there's so many possible correct answers. So usually people like doing these because it's easy to get them right. So any questions on 6, 7, or 8 before we move on to the last two?
Are we going to do the graphing test?
No. You should be able to draw an S orbital. You should be able to draw a P orbital. And remember, you've got those objectives. That's the very first sheet in our packet are the objectives for quantum mechanics. We'll go over the plan for the week after this worksheet. just have a couple more things to get done. We're pretty much done now. For fluorine, again, there are a lot of different possible answers. Now we have 5 electrons in the P, 1, 2, 3, and then the last 2 have to be spin down, but you could do that and that. You could do that and that. You could do that and that. So any of those are good answers. I think it's easiest if you just put them in the first 2 boxes. And that's how I get to have +1, 0, and 0. Here 1 spin up, 1 spin down, 1 spin up, 1 spin down. And for the last one, all of the orbitals are filled, so there's only one possible correct answer. So any questions on the homework at all? Okay, then you can put that away. So this is the first sheet of your packet where we've got the goals. And we've just about covered everything. We need to do valence electrons. We need to do electron configuration for ions. But the rest of this, so there's only really 2 objectives left. You know what an orbital is. It's a probability graph. What's the shape of an S? Sphere. What's the shape of a P orbital? Dumbbell or bow tie. Look at, what do we need?
When the bell rings, Stephanie Doherty's not my office. Thank you.
All right. So when will we test? So today, for homework, you're going to get orbital diagram number 2. And Wednesday, let's see, I think we should be able to test on Wednesday. Because we should be able to cover these 2 objectives pretty easily today. So review for test. And then we're going to take quantum theory test on Wednesday. I do have a practice test for you, and I want to give that to you now before I forget.
You okay, Adam?
Yeah. Just meditating on how much fun tests are. I do that often too. This is not homework, this is optional. So I highly suggest you do it, because this is what your test is going to be like. Probably there's probably some questions on here that will be on the real thing. Because there are only so many ways to review a question. And then the answers. Try not to look at the answers until you've done the practice. And this test is a lot of points. It's probably about 60 points. So you really want to take some time to study. Take it one any of those. Answers? So if you're not understanding what's on that objective sheet, come in and get some extra help. Go to the Khan Academy. Go to Mr. Isaac Teach. Find an AP Chem student. So one thing I want to review with you is the rules for completing electron configurations and orbital diagrams and being able to build the periodic table. So we're going to, if you have a pen or a pencil, we're going to fill in the periodic table here. So when we have an electron, one electron, we put it in the lowest available orbital, which is the 1s. So when we fill out our periodic table, the very first electron is in the 1s1. After the 1s1, then we fill in the 1s2, right? Correct? Now, after we fill the 1s2, then what do we fill? 2s2, right? So if you want to refer to that, you can. So after the 2s1, then we fill the 2s2. And then what do we fill after the 2s? The 2p. So this is 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. After you fill 2p6, then what do we fill? The 3s. So then it becomes 3s1, 3s2, and then what do we do then? We fill the 3p. So this becomes 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Now, after the 3p6, what do we do next? 4s1. Remember, there's that overlap. After the 3p, we don't go to the 3d, we go to the 4s. So it goes 4s1, 4s2, then we fill the 3d. So this becomes 3d1, 3d2, 3d3, d4, d5, d6, d7, d8, d-lovely, d10. After the 3Ds, then we go to the 4Ps. So this becomes 4p1, p2, p3, p4, p5, p6. Then we fill the 5s1, 5s2, and then we fill the 4ds. So by now, you should be seeing a pattern, right? First thing I want to bring your attention to is the D's are shifted off one. You don't have to continue to fill the whole periodic table, unless you want to. I just want you to see the pattern. So the first two columns is where we fill the S's. That's called the S block. In the middle, where we have the transitions, that's called the D block. And then here, we've got the P block. And on the very bottom, those are the F's. And the F's are shifted off. So this is 4F1, 4F2. This would be 5F1, 5F2. That's the F block. But again, make sure you remember that the D block is one less than what it starts over here in the S block. So when it comes to the test, you now can give me the electron configuration for any element on the periodic table. Okay? But you will not be allowed to use this on the test. So now you're probably thinking, how the heck am I going to remember the filling? Well, you can remember the filling by memorizing this is the S block, that's the D block, that's the P block, and that the D block is shifted off one. The other way you can remember it, the filling, is a very simple memory device, Sam. Can you count to 7, Sam? Okay, that's good, because you need to be able to do that. I think I'm just going to use a permanent marker here. So to remember the filling, the first thing you do is you write down 1, 2, 3, 4, 5, 6, 7. Okay. There are only 7 rows on the periodic table. Now, in theory, it can go on to infinity, but in reality, elements stop in the 7th row. Then you have to remember it goes S, P, D, F. So that's the kind of the one memorization thing. S, P, D, F. So you write 1S, and then you go 2S, 2P. And then it goes 3S, 3P, 3D. 4S, 4P, 4D, 4F. 5S, 5P, 5D, 5F. And the periodic table only has S, P, D, and F. But in mathematical theory, it continues out. The next one would be alphabetical 5G. If you want to see what a G orbital looks like, go to the grand orbital table and on the internet, and you can see what they look like. 6S, 6P, 6D, 6F, 6G, 6H, 7S, 7P, 7D, 7F, 7G, 7H. Whoops. 7I. So the filling goes this way. You start down here, the first thing you do is you fill the 1s. After the 1s, you fill the 2s. After the 2s, you fill the 2p, then the 3s. After the 3s, you fill the 3p, then the 4s. After the 4s, you fill the 3d, then the 4p, then the 5s. After the 5s, you go to the 4d, then the 5p, then the 6s. And after the 6s, then you go to the 4f, the 5d, the 6p, and the 7s. And that's where we stop. So when it comes to the test, I'm going to ask you to give me the electron configuration for any element in the main part of the periodic table. We're not going to do the F block. The F block, weird things happen down there. But for any other element, you should be able to give me the electron configuration for. So how about we try, nobium. That's a good one. Hey, Trevor? Nobium is NB. Nobium is right here, number 41. Now, you can fill in all 41 electrons if you want, and follow your pattern here. Actually, did I tell you the shorthand notation yet? No. Okay, let's do an easier one. Let's not do nobium. Let's do calcium. 20 electrons. 20 electrons. So, if we're going to do calcium, with 20 electrons, first we fill the 1s, then the 2s, then the 2p, then the 3s, then the 3p. After the 3p comes the 4s. That's calcium. Except I forgot a 6 there. That's the electron configuration of calcium. So that's 20 electrons. It would be a lot of work to do something like mercury, which has 80 electrons. So there's a shorthand method where I use the noble gas core configuration. If I were to do the electron configuration for argon, that's it. 1s2, 2s2, 2p6, 3s2, 3p6. That's argon, that's calcium. This portion is identical to that portion. So instead of doing all of this, the way you can write calcium, according to the shorthand notation, is you go to the previous noble gas. So here's calcium. The previous noble gas would be argon. So I write argon in brackets. And then you have to count off what you have left. So here's argon. And then what do we have left to get the calcium? 4s1, 4s2. That gets me to calcium. So I would have argon, 4s2. So now that you know the secret, Lexi, you can use the shorthand method. All right? If you want to do the longhand method, that's fine, but you probably want to do the shorthand method because let's do mercury. 80 electrons. So we probably don't want to write out 80 electrons. So what do? Here's mercury, element number 80. Who is the previous noble gas? Xenon.
You can only use noble gases.
Can only use noble gases. So then we start in row 6. This is the S block, right? So it goes 6s1, 6s2, and then we enter the D block. But remember, the D block is one less. So it's not 6D, it's 5D. So 5D1, 5D2, 5D3, 5D4, 5D5, 5D6, 5D7, 5D8, 5D9, 5D10. So mercury is xenon 6s2, 5D10. Any questions so far? Now, it wouldn't be chemistry unless there were some exceptions. And if you flip that periodic table over, I gave you an overhead of the exceptions. These elements do not follow the pattern of filling. And you can see the further you go down the periodic table, the more of them that don't follow the pattern, especially down in the F block. That's why in the test, I'm not going to give you anything from the F block, and I'm not going to give you any of these where there's an exception. Okay? So, I will only give you elements that follow the rules. When you take AP Chem ME, then you can play around with these weird ones. Okay? Oh, I suppose there's one last thing we can do on here. Define valence electrons. Valence electrons are all the S and P electrons in the outermost level. Valence electrons are all the S and P electrons in the outermost level. And then the core electrons are all the rest. Now, sometimes you'll see core spelled with a K because they were Germans doing all this research. So sometimes you'll see it spelled the way Americans spell it with a C. Sometimes you'll see it spelled with a K. So just an FYI, Malky, if you see someone spell core like that, they're not crazy. They're just following the old German writing. But let's just stick with core. All the rest. So the valence are all the S and P electrons in the outermost level. The core electrons are all the rest. So let's see if we can identify the valence electrons of mercury. So first of all, we have to find all the S and P electrons in the outermost level. So what is the outermost level? The 6 or the 5? Which is the outermost level there, Stephanie? Which is bigger, 6 or 5? Right, 6. So, whatever is the highest number, that's the outermost level. So all the S and P's in the outermost level, so these are my valence. Everything else are core. So it's only the S and P's. These are never included as a valence. For calcium, where are my valence electrons? Well, which is the outermost level? 4. So I have 2 valence electrons there. I have 2 valence electrons here. What about argon? What's the outermost level? The 3rd. All the S and P ones, Jared. S and P. So that's all of those. So that means I've got 8 valence electrons there.
What if you were doing the F? Is the F be diagonal?
If what?
If you're doing, not now, but like if.
F
let's
for
say-
D block?
Yeah.
They are not included. So, and remember the D block and F block, they're always one number lower. So they wouldn't be in the outermost level anyhow. So it's always only just S and P. Now, what's so important about the S and P electrons, Lexi? I'm glad you asked. Those are the ones that are involved in bonding. Okay? So when two elements want to share electrons or steal electrons, it's always from the valence. So when we want to predict how something's going to behave, we look to the valence electrons. We ignore what's going on in the core. The electrons in the core, they don't do anything. So any questions so far? It's kind of rough on a Monday morning. All right, let's get an orbital diagram worksheet number 2.
I feel like you should move this up.
Okay, let's do a couple of these together just so you know what to do. So, for the orbital diagram, they really got this kind of backwards. I would do the electron configuration first before you do the orbital diagram. It'll make your life a little bit easier. You can use the shorthand method. Okay? And for your valence and for your orbital diagrams, valence only. That way you're not like spending 2 days writing out boxes and circles doing orbital diagrams. If you're only doing the valence, you're only doing the S and P's in the outermost level. So for nitrogen, if we want to use the shorthand method, the previous noble gas would be helium. Now for nitrogen, it's probably not that big of a deal to use the noble gas cores, but now we count off. Second energy level, 2s1, 2s2, 2p1, 2p2, 2p3. So nitrogen would be 2s2, 2p3. So now, when we do the orbital diagram, we're only doing it for the valence. So that would mean our S's and P's. And so, the orbital diagram, the information that it tells us, which is important, is there are 3 unpaired electrons. And basically, if we use some analogies here, Sarah, I got 3 single friends looking for dates. I got 1 couple over here, they're all set. So, in our next unit, we're going to be talking about bonding. And it's the number of unpaired electrons that depends how many things you bond to. So nitrogen has 3 unpaired electrons. Nitrogen's going to form 3 bonds. But that's kind of a foreshadowing, a taste of what is to come, Trevor, to whet your appetite for the exciting world of chemistry. Okay, let's try a different one. How about woo? Let's try. Oh, that's a good one. That's a good one. How about H? now it gets a little tricky. So now we're doing an ion. So first you got to look at what does normal sulfur have. So normal sulfur is element 16. That's why they're giving you the number down there, Callie. It's just to help you find it on the periodic table. So when they give you the number down here, that's just so you can find it. So sulfur is element 16, which means it has 16 electrons. That's normal sulfur. Now this is where people kind of make a mistake. If it's -2, it means it has 2 more electrons. So if it's got a negative charge, it has additional electrons. So 2 more, so that means I've got a total of 18 electrons. So noble gas core, the previous noble gas is neon. And neon has 10 electrons, so that takes care of the first 10. And now we count it out. 3s1, 3s2, 3p1, 3p2, 3p3, 3p4. And now our 2 more electrons, 3p5, 3p6. Yep, Garrett. Because the rule is you got to go to the previous noble gas. When you join IUPAC, you can change the rules. So now let's do the orbital diagram. And the orbital diagram, again, just the valence. So sulfur with a -2 charge, everybody's paired up. Everybody's got a date to the dance, the element dance. Yep.
Now what do you do for noble gases? Do you have to, you just...
Again, you go to the previous noble gas. Okay.
Wait, for the pluses it means negative?
So with the pluses, you'd have fewer electrons. So how about we just kind of start zinc? So zinc with a 2+. What does normal zinc have? Well, they give you that number down there. Normal zinc has 30. But if it's a +2, it's actually losing 2 electrons, so it's going to have 28. So again, you go to the previous noble gas, and the previous noble gas is, oh, we're doing zinc. So the previous noble gas would be argon. And then we count it up, 4s1, 4s2, then what comes next? 3D. 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7, 3D8, 3D9, 3D10 would be normal zinc. But since we lost 2, it's going to be 3D8. So it's going to be 4s2, 3D8. Now when it comes to our orbital diagram, do we write out the D's for our orbital diagram? No. Only the S and P's in the outermost level. So we're only having to do those 2 right there. So there, I'm done with my orbital diagram. So instead of having to draw 30 circles, I only have to draw 1. Okay. I think I'm going to not give you this as homework. I think I want to see you do it in class so that I can help you with this. So I'll give you maybe about 10 minutes in class tomorrow to work on it. And then we'll push everything back one day, okay? So the test will then be Thursday. We'll review on Wednesday. I just feel like I want to walk around and be able to see if you're doing it right instead of going home and doing it all wrong. Yep, Garrett.
What do you do for F?